All right, so this is the data that we gathered when we were from the sensor. As you can see here, there was essentially this should have read a 0 force. Didn't, so we'll adjust for that. But basically, it was going along, and then the rocket engine fired. You saw the force go up to almost 11 there, and then it came back down. The secondary bump was when it blasted the backwards for when it normally ejects the parachute. We're not really going to worry about that, but for the rocket project, we want to bear in mind what this average is right here, and also, sorry about that, also the count.
151.
Okay, so I went ahead and showed this. We checked this. It's 3.72. And so if you take the mean, if we go over here, and then subtract where it should have said 0, this is an adjustment. So in fact, our average force for this rocket as it went off, the average force would have been 2.65 newtons. And then the count tells us that it's 15/20ths of a second, which is, so the time would be 0.75 seconds. Those are two pieces of information you need to know to calculate a theoretical height. And then finally, you're going to need to know the approximate mass of your rocket. Now this is a different one, but for all practical purposes, we could just assume that, glue might be different, but that this would be pretty close to the same to one that you would build. And we need to remember to add in the rocket engine. So although the mass of it without the rocket engine is 16.7, we got it, and then we're doing an A size engine here. We're going to put that on there. Your total mass is 33.35 grams, and this is for just a standard rocket that would be built from one of these kits that we have here. That should be all the information that's needed. Also, it will be we're going to launch them the best we can at a 90-degree angle from the horizon.